Welcome to Unit 3, Task 1 of Math 2. In this task, you'll begin your experience with circles, and you'll start with the sun, as shown in orange, that's falling below or beneath the horizon. I was going to say falling into the ocean. Well, as you can see in this image, and as I zoom in, you create a chord. And a chord is this line segment from this red dot to the other red dot. As you look through your links or resources in instructional materials, mathopenref.com is a great website that goes into detail and gives you an explanation of not only chords and arcs, but almost everything that there is to learn about circles. As I zoom back out, let's take a look through some of the key points of this task. In questions 1 and 2, they're looking for your opinions, not necessarily fixed correct answers, but what you come to know about whether or not the circle is a perfect representation of the sun, and they almost lead you with the question, why not? In the next part, they ask for different types of intersections between the sun and the horizon, and be sure you illustrate that. Again, here is a great example with the sun, intersecting with that blue line. You'll come to learn that that blue line would be a secant line for a circle. As you scroll down to number 3, they're asking for you to more or less compare and contrast tangent and secant lines. Tangent lines are important because tangent lines create 90-degree angles and only touch a circle at one point. Well, I'm not going to give you what secant lines are. That's for you to do. Again, use those instructional resources. In number 4, you also have other questions, but then again, in order to answer them correctly, you need to understand what chords are, what tangent lines are, what secant lines are. In 4E, there's a conjecture that's proposed to you, and you're supposed to use what you've learned through those resources to determine whether or not it is true or not. Shucky. Let's try that and that. Okay, now, of course my drawings, are not the best. I could certainly take my time to make them a little bit better. But let me just read F for you, because you'll be doing that, I believe, in the next task. Ralph was looking at the figure to the right. He made the following conjecture. A radius perpendicular to a chord bisects the chord. Prove it to be true. Actually, you can do it here. I actually decided to edit this part into the video just to be sure that you are successful at making the decision of whether or not a radius perpendicular to a chord can actually bisect that chord. Looking at the two triangles that I kind of tried to illustrate, not saying I did the best of jobs, and I'm actually going to try again. I want you to also think back to some theorems from years past, particularly last year. No, that's not going to work. I'm going to have to do it freehand. But that looks good. Okay. Anyway, if we know that this angle is 90 degrees and it points to this side, we then also know that this angle is 90 degrees and it points to that side. So right now we know the hypotenuse for both, didn't want to write the L. The hypotenuse for both triangles are the same. And I'm going to then get rid of our arrows. Also, we have two triangles. We don't know anything about this bottom side or that bottom side. Okay, they could, for whatever purposes, be different. However, we know that we have one triangle on the left and one triangle on the right, and they share sides. This side right here. So we know the hypotenuse for both are congruent, and the side or the leg for both are congruent. So kind of gave you a hint earlier. There's going to be a postulate And you can refer to it as a theorem. But it would be more of a postulate because we know it to be true. But it's kind of like in the same, it's thinking just like SSS, side, side, side. It falls in that realm of geometry. SSS, SAS, ASA, AAS. Did I say SAS? But this one in particular is only for right triangles. So hopefully you are successful with the rest of this task. And this, well, let me go ahead and do number 5. In number 5, they're talking about arcs, the arcs that you were dealing with your, well, I can't scroll down. The arcs that you're dealing with your original circle. They make mention of minor arcs and major arcs. The key difference is, for instance, if you were to go with the circle we do see, across from E up and then back down to D, that would be a major arc. But if you were to go from E through F and F to D, that would be a minor arc. Now there's a certain requirement for an arc to meet, and once that requirement is met, you can call that arc a semicircle. Well, then you have to kind of understand what a semicircle is. But then you also have to understand what a circle is. A circle is so many degrees. So a semicircle or a semicircle would be blank degrees. Hopefully you're able to answer that. Now, again, I promise you,